Kirk Math. All right, ladies and gentlemen, we are starting our new module, Module 8, and we are looking at 8.1. Our goal in this lesson is to be able to solve a system of equations by graphing on a coordinate plane and then seeing where the line intersects as our answer. So we'll get out your notes because we are going to go ahead and write down our key terms. So the things that are most important in our key terms would be the things I'm going to highlight here. So make sure you write those down. If you write down everything, you'll just have all of the pieces of information. So a system of equations is when two or more equations share variables. So for example, this example here shares an x between the two equations, and it shares a y between the two equations. So therefore, these two equations we would call a system of equations. Okay, and then the example, which is on your notes already, is shown in the graph. So they graphed these two lines here, and you can tell that where the two lines meet, right here, would be our solution. So when the lines intersect, we have one solution. Okay, and the solution for this problem is 1, 5, because we're looking at x and y, and the x is at 1 and the y is at 5. So where the two lines meet is 1, 5. That is our answer. All right, so we're going to go ahead and start to practice solving these equations by graphing. So use a pencil, it actually should say a ruler. Use a ruler to be accurate because a ruler is going to help you stay nice and straight. I'm going to actually end up using, hold on, my little shapes here. So let's go ahead and grab that. Okay, so the way that we graph equations, which you should remember from past modules, is we're going to graph the y-intercept first. So the y-intercept in this equation is positive 4. So I'm going to go up to positive 4. Okay, and that is going to be, let me actually go back here. This is going to be my first point right here, positive 4 right there. Okay, now I am going to go ahead and graph my other points by counting the slope, rise over run. So my slope in this first equation over here is -1, because remember there's a little 1 in front of this x, so my slope is -1 over 1, meaning I'm going to go down 1 over 1, down 1 over 1. And I'm going to do that repeatedly until I have multiple points. Then I can use this line right here, like drawing a line with a ruler, and I can make sure to go through those points and make a nice straight line right here. Okay, let's see, where's my shape? Oh, here. All right, so I want to make sure that that's easy for you to see. There it is. Okay, that is my first line being graphed. Okay, my second line that I'm going to graph is going to go ahead and be this line right here. So this line does not have a y-intercept listed, which means our y-intercept is 0. So I'm going to start at 0, and then I'm going to do my slope. This is 3 over 1. So I'm going to rise 3, 1, 2, 3, run 1. Rise 3, run 1. Remember that when you're graphing, we want to go up and to the right or down and to the right. Okay, we always want to go towards that right-hand side. Okay. So now I can take my shape here, my line, and I can start drawing through my points. And as long as my points are all connected, I should get a nice line right there. Okay, once you've connected your 2 points, you should be able to see your final answer, which is where the 2 lines meet. So this purple point right there is my final answer, and that is at 1, 4. 1, 4. Okay? All right, so we're going to do this again. Ready? So we're going to start with this one up here, and we're going to graph this line. -3, 1, 2, 3. and then my slope is 3 over 1. So I'm going to go up 3 over 1, up 3 over 1. Okay, once I have enough points, then I can start to draw my line through them. So on this one, I'm just going to try to go as straight as possible. All right, now I can go ahead and graph this equation right here. Okay, now on this equation, notice that I have distributive property right here. I have a parenthesis, so I'm going to need to multiply out. And I'm going to get y equals 3 times x is 3x. 3 times 1 is minus 3. Uh-oh. Look what I found. This equation is identical to that equation. So if I were to go and make this line, it would be exactly the same line. So my two lines are going to lie on top of each other. And that is going to tell me that there is multiple answers to this problem, but we're going to learn about that more in 8.5. Just know that if you get the same solution, the same equation, that you would basically have one line on top of each other, okay? There's not really a point where they intersect, so we don't have one answer. Okay, so now this is where it's going to get a little bit tricky. All of the lines that we've seen so far have been in slope-intercept form. That means that they've been in the form of y equals mx plus b. Sometimes, though, you're going to see equations that are not in y equals mx plus b form. So if I actually go back to our key terms, this equation here, these two equations are in what we call standard form. And you're going to graph and learn about standard form in high school, in algebra, but what we know is slope-intercept form. So I'm going to teach you how to take standard form equations and convert them down to slope-intercept so that we know how to graph them, okay? So let me get back to my page here. There we go. So we are going to go ahead and write two equations. They're going to be in standard form, and then I'm going to turn them back into slope-intercept form, okay? So we have Keisha and her friends are visiting a concession stand at the football game. The stand charges $2 for a hot dog, $1 for a drink. The friends buy a total of 8 items for $11. I want to know how many hot dogs and how many drinks they bought. Okay, so knowing that I'm eventually going to get in this format, there are going to be two variables that I need to find, a y variable and an x variable. If I look at my problem, there are two things that I need to find. I need to know how many hot dogs and how many drinks. Those are going to be my two variables. So we're going to let x equal hot dogs and y equal drinks. Okay, based upon the word problem, I can write two equations with the information provided. So I know that they spent $11 and that each hot dog costs $2. So $2 times the number of hot dogs plus $1 times the number of drinks equals a total of $11. Okay, that is my first equation. Now, they also tell me that there is a total of 8 items. So I'm going to go ahead and write an equation for the items. So we have, I don't know how many hot dogs, plus I don't know how many drinks will make 8 total items. These are my two equations that are in standard form. So what I need to do next is convert or change them into y slope-intercept form. Now, if you notice, slope-intercept form, one of the things that makes it special is that the y is all by itself on the left-hand side of my equation. Excuse me, in my equation. So I need to make sure that y gets isolated, okay? So over here, I want to keep y on the side by itself, which means I need to get rid of 2x. So I'm going to subtract 2x from both sides, and that's going to get me y equals minus 2x plus 11. There is my equation in slope-intercept form. I can now graph that, okay? I can go up to 11. I can go down to over 1, down to over 1, and I can draw my line. My almost straight line through my graph. Okay, this is why you should use a ruler. Okay, now I'm going to do the same thing for the other equation. I need to turn it into slope-intercept form. So I want to keep y by itself. I'm going to keep the y here, and I want to get rid of that x. So I'm going to go ahead and subtract x from both sides. Remember, I want slope-intercept form, so my x stays first, minus x, and then I add 8. I cannot add x and 8 together. They are not like terms, just like how I could not add minus 2x and 11. These are different things. Think of this like I have 2 negative x's and I have 11 tally marks. I can't add those together. They are separate things, okay? So now I have my other equation, y equals negative x plus 8, and I'm going to graph it. So I have an 8 here, and then my slope is negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and I'm going to keep doing that, and then graph my line, which is a lot harder to do on the computer. Whew, there you go. Okay. So there are my 2 points, and it shows me where they intersect. Actually, these points are quite horrible, so let me actually get out my straight line, and let's redraw these again, okay? So this is going here. There we go. All right, and I want it to be nice and large so you can see it, and then I'm going to take another one. Okay, and I'm going to make that go through all of these diagonals. There we go. And I'm going to go ahead and make that nice and large. So now if I get rid of my really yucky lines, you should see where the two are meeting, where that should be a lot more clear, right? This is not. There we go. Okay, so now I should be able to see that right here is my center point. And this is a lot easier on paper than it is on the computer. You should be able to get this a little bit easier. So my answer would be 3, 5, because I'm here at 3 and 5 on my x and y axis. So that means that 3 is x, 5 is y. So go back to the beginning. How many hot dogs do we have? We have 3 hot dogs. How many drinks did I buy? 5 drinks. And this is how we solve our problem. Now you might be thinking, Ms. Kirkwood, how do I know if I'm right? Well, you're going to do something called checking your work. Okay, so to check your work, we are going to, oopsie, where'd it go? We're going to go back into our 2 equations that we did. We're going to go back to this equation and this equation, and I'm going to replace 3 with x and 5 with y and see if it works out. So if 2 times 3 plus 5 equals 11, then I know I'm right. Okay, 6 plus 5, does that equal 11? Yes, I am right, because 11 equals 11. Then I'm going to do the second equation. Does 3 plus 5 equal 8? Okay, yes, 3 plus 5 equals 8. Because I checked my work, I know that I am correct, and I can be done with my problem. Okay. All right, let's do another example really quickly. So during school vacation, Marquise wants to go bowling and play laser tag. So we're doing bowling and laser tag. He wants to play 6 total games, but needs to figure out how many of each he can play if he spends exactly $20. Each game of bowling is $2 and each game of laser tag is $4. So we're going to write our 2 equations, very similar to the hot dog and drink one. I know that he wants to play 6 games. So the number of bowling games, hold on, we're using x and y. So let's make x bowling and y laser tag. So the number of bowling games plus the number of laser tag games needs to equal 6. And he can only spend $20. So 2 times the number of bowling games plus 4 times the number of laser tag games equals $20 total. So now I'm going to go ahead and rewrite these into slope-intercept form. All right, now that I have slope-intercept form, I can graph these and see where they land on my coordinate plane. I'm going to go ahead and pause the video and do this on my own so you can check your work. All right, so check your answers with me. I graphed my 2 lines and I got this intersection here at 2, 4. So he can do 2 bowling and 4 laser tag games. All right, and this last problem in your notes, you're just practicing that basics again. They're already in slope-intercept form. If I graph my two lines, I should get -1, 3.